Friday evening, supposed to be resting time, and some of you are on the holidays or some national days. So yeah, thank you for joining this session. So today we will conclude the training. We will give the based on the attendance, you will get the certificate. Okay, so let's get started. Okay, today we will talk about raw data and records. So let's do a quick review. I know a lot of people are still signing in. That won't because you are here. That won't have any impact because this is a review you learned already yesterday. So let's do a quick review. Okay. Well, I'm teaching at a university. This is the style. Sometimes I do teach this way. When you learn something, a good thing, go back to do a review. So it's some kind of a summary. Okay. So we learned yesterday about lab analysis. Related to GOP, related to lab practice. We talk about a lot of things about LOQ, LLMV, and we use these very commonly to explain the method. So this is a requirement. You have to do enough lowest level, spike level in order to do the statistical calculations. So in IR4 system, based on EPA requirement, the LLMV level, we need to do at least 6 samples, this level. So this is IR4 system, but a different country may have different requirement. I know some country requires 7, because that's easier to calculate using that student t-test constant. So that number is 3.14. So when you do the work, check the requirements. Then we talk about the standards must be GOP. If the standard is not GOP, then your work may not be accepted. The next we talk about the reference method. Sometimes we call that the enforcement method, because the government will require these methods to do certain work like registration, like monitoring. So sometimes this you can do yourself, you can develop the method, but that's getting another area. So we are not talking about here. Then we talk about the method validation. We talk about even storage. So it should be triplicates. We talk about a lot of things about approval from the study director. And this will be going with you when you do the GOP work or all those government-related, the regular, let's say registration-related work for the residue work. So then, because we talked a lot of time about the method, then the next thing is when you don't use exactly method. So the next is what's the change? It's accepted. Okay. So so here is the reference method. Then you have your own working method, and what's the change? So that could be very minor, small, or could be very major. Then we talk about we showed some photos of how you do the balance checking and pipette checking sort of thing. So it's all depends on your SOP and the requirement of the work. So you should do that accordingly, but this is the requirement. This is GLP requirement. Then we talk about definition about the sets. What is a set? So what's the requirement? What's the sample? It must be in there. And you can have multiple sets in one sequence when you run the sample, do the extraction, and the analysis. So there's a data, duplicated data there to do double injection and what's the acceptable criteria there and linearity there, or all those calibration thingies. Also, I did mention very briefly, if your residue is very high, you need to have the validated level to cover this range. So the last thing we spent probably about 5 minutes talk about the data acceptance requirement. So it is which requirement sometimes is the protocol, sometimes the different countries requirement, sometimes it's the lab requirement. These are all science related plus the regulatory. So that's what we learned yesterday. So let's see what we need to get started. So I see 40-some people here. Let's look at our agenda. This is what we did yesterday. So we did not have enough time to do the checklist. We did not have enough time. So we will move this down to here. We probably, because we don't have that much time, we probably will remove electronic data, just talk about the data. So today's schedule will be data, raw data, and reporting, which is like an analytical report. So we will do the QA checklist first. Okay, then we do the discussion. Then let's see what questions we have before we adjourn the meeting. Okay, we have more than 40 people. That's a good turnout. Thank you for attending today's session. I just say one more time. I know you may have a lot of people in one room. Please send in your name and the email. And yeah, we will use the name to give you the training certificate. And also we need this attendance for this purpose, for the evidence. Okay, so we do this QA checklist first before we move on today's scheduled training contents. Okay, let me make this a little bit bigger. Okay, some of you may or may not see this kind of a training, a checklist for QA checklist, but that's a good resource for you to understand how QA, how inspector will check your work, what is required, and what is their point of view to see your work based on the regulations, based on the science. Okay, let's get started here. So we see this is typical one, IR4 work. Let me make this one. So you will see IR4 project, and this is for analytical raw data. Of course, raw data, your report, and all those things, you can do one inspection, but you may have two different reports. So that's QA's work, and they may combine. So let's talk about the raw data this time. If the report need to be, this is testing facility manager, which is management, study director, and sometimes it may be more people. So typically you just check here to sign. That's QA's work. We have the same thing. So what is the study? So this is all about the study. So that's similar to the content about the report. So what is study? So in this case, that would be mitigation or something in your country. This is pesticides. That would be mitigation or whatever. Okay, let me just write it first. It's difficult to write. Mitigation using a mouse. Okay. Okay, so write it down there. Then you have the lab ID or field-related work and date. Then who's the lab LRD, lab research director, and etc. information. Okay, then the QA information, put it here, or it could be not necessarily the local QA, could be the contract QA, could be other people. Anyways, that's the inspector. So the contents are here. So we still see exactly the same format we talked about in the past 3-4 days. If we see any star or any asterisk, like a sign there, that means this is required by GLP or the government, the guideline. Like in this case, it's the EPA guideline. I think it's 860. So the general information. So the work. Do you have the protocol? It's approved protocol, and all the method related in the package. So basically, you're going to look at, do you have that? If you don't have that, that means something is missing. So it should be always approved. So typically, they're going to put a check mark there, say you did that. Then you will see all these. Do you see any change? We know that. We know the method could be the change, it could be the protocol change, or could be the SOP or related work. Then study director will review and see this is an impact on the study. So if there's no impact or something, study director will say this is okay. But for the QA, we'll say if it is there, if it is approved. So when you prepare your work in the laboratory, this is something. Okay, you do have some change, you do have something, and the first thing you need to know, talk to the study director. So that's why in the IR4 protocol, you will see a lot of times to mention even the laboratory session in the last 6-7 pages. That's a lot of wording like this. Talk to the study director, get approval from study director, communicate with study director, contact study director, etc. So that's very typical. Then we can keep going on the details. Let's go a little bit quickly because we have a lot of contents there. So this is all about SOP, all about the data, the general information. So we will see this is all about the general things. So you have any change, any deviation, something. And basically you will see a lot of times about the study director, approval, procedural, or details. Okay, so you can see that. Okay, move on the second portion here. B is sample storage and the preparation. So all those are the things we went through. It's just like, okay, you have a sample. Do you have the tracking system? So in this case, we have the chain of custody form. Okay, each sample, you will have the record when it arrives when the sample arrives in the lab. So you will have all the information. You will put everything on there. Then starting this point, you will make every single point where your sample is. Who is responsible and what is the sample condition? So you have received here. You have all the storage condition and all the route it goes. Okay, so that's exactly what we talked about that. And all those things, you do need an SOP. So how you follow that. Even this is sometimes it's not necessarily very common. For example, if this is one-time thing, if the lab activity is one time, you still need to have an SOP. Sometimes, oh yeah, I don't have to. No, so it's just like a document you need to follow. So that's always we talk about. Do you have document? Do you have SOP? And do you record them according to the SOP? And the activity is valid and sound according to SOP, according to the protocol. Then we talk about sample prep and all those. Okay, say grinding and all the method is good. then method validation, and location. So that's probably most of them should be all related to the sample, sample chain of custody, and the storage condition. So we need to have all those. So when we talk about the storage, and the first thing we need to know is the temperature. So based on the science, we know that the temperature is the key. If you, that's the pure science. That's a reaction. Okay. If we say chemical reaction, we know the science is, this is the function of the temperature. Let's say we use temperature T as the temperature there. That's the absolute temperature. Okay, so we can do the that reaction rate. Okay, so in this case, we know that's you can do the calculation. There's a lot of a constant there. That will be a constant times the E to the power of the activation energy divided by the gas constant and the T. So for a specific condition, for a specific chemical like a pesticides, most of them is the constant except this T. So if we know the temperature, we pretty much can calculate based on all those things. So the temperature is very important. It needs to be maintained negative 20 degrees. Okay, otherwise your sample is not stable. So that's typical storage condition. Okay, so all those date and time, all those things related to sample because the temperature is very important. So if you leave your sample in the room, in the lab room, like for 24 hours before you put it back in the freezer, the sample is no good because your record will tell it's at room temperature. Typically, room temperature is around 20, 25, or 30 degrees. That's positive. Then it's not good. Okay, so typically it's just by how many minutes. And then when you weigh the sample, you need to wait when it's frozen, and they do it immediately. Do the extraction immediately. So that will minimize the impact on the study. So then we move on the next, then it's all about the standards. This is about the standards. So the standards, then you go that, then we have the same thing. We talk about the log, we talk about the label, we talk about the records. Okay. Go back, go a little bit more. Then we talk about the data. So now, which we will be talking about the data today a lot. Yesterday, we spent some time talking about data. Okay. The printout, what is the raw data we will talk about today, and etc. Then the unit, those things. These are all science and the GOP requirements. And okay. The recovery, so this is something we talked about yesterday. The recovery should be in the acceptable range. We have the criterion there. That's ODOQ. So you will see this is all GOP requirement. And you need to show the calculation. For example, we will talk about, do we talk about that? Maybe we will not. When you show the calculation, this is an interesting thing. You cannot simply print out the results from the instrumentation. If you run LC-MS, for example, and if you have all the parameters entered correctly, the instrument typically can print out all the things. Let's say print out. You can print out the area count, this is oops, that's wrong. This is the wrong one. Okay, I was thinking. Sorry, I was going back and forth, which is here. Okay, so the instrument software will print out the results. Okay, so in this case, And most likely those results are good and valid. It should be fine. But the thing is, when you do the calculation, you cannot simply rely on that. And also you need to show everyone you have enough evidence you can calculate it yourself. For example, you need to give in the report, in your raw data, you need to give all the necessary information for other people to do the calculation, not just simply print it out, because you can print out the final step. So for example, in this case, you need to give the area counts for every single injection data, the calibration. So you need to give all those things. You need to give all calibration parameters, or how you do the calibration. It's linear regression. Is it you use the weight, and what kind of the range you use? So, and people can pull out themselves, then do the same thing. Then you can use Excel to do that. You do not have to. You can use your calculator, or you can use all kinds of valid scientific tools to do the work. Then you can get the same results. So in this case, your result is accurate. And this is important because you don't rely on one method. Sometimes there will be a mistake. Sometimes you select the wrong parameter. For example, for the instrument, like LC-MS, if you select a different parameter, your result will be different. So a lot of times people say, are you doing this right? And have you validated this? So in this case, you have to show all the ways for people to calculate themselves, not only rely only your printout. So that's important. So this is a typical the GOP requirement. You don't just print out from something you don't know. You need to validate that. Electronic data, there are your own lab data from Excel, from all the work. Okay, we spent about 10 minutes, 15 minutes talk about what we learned yesterday, and this checklist we're supposed to talk yesterday. So after this checklist, we know that's the normal general theme. That's QA finding. We'll list everything here, and you get response one by one. This is one. You need to explain one here, and you have two. You need to respond to for every single one. So that's the checklist. Okay, let's minimize that. Let's go back to this. This is what we just overviewed, what we learned yesterday. Any questions so far? If you have questions, please type in the chat box so I can answer the questions immediately, so we don't have to wait too long. Oh, I see outside the window starting to see a little bit of sunlight, a little bit. It's 6:24 in the US at New York time. Okay, let's do the same thing. I'll do a little bit of quick true and false. We have time. We can talk about this later at the end of the presentation. Yeah, so it's a good thing to check how much we learned. We learned through yesterday's lessons, trainings. Okay, we got a true and false. Okay, we talk about, for example, we talk about the changes. Okay, so this minor change or major change. Is this minor or major? In this case, for example, if we change the extraction method, okay, if you change that, is it minor or is it major? Or you change the solvent. If it is a solvent, it's changed. It's bigger or small. So, yeah, I'm not going to talk about this now. If we have time, we can talk about this at the end of the presentation. And the same thing if we change instrumentation. Okay. And how about your pipette? Okay, so how you practice in your lab. So that's something. Just take a quick look, and well, you don't have to type in the answers now. You will get this presentation file, I mean all those days files shortly, so we will put it on the server for you to download. If not, we will email you those files, so you will get the same thing you see on the screen. Okay, so what is the raw data? Okay, so true or false. So for example, the raw data should contain the signature and date of the time, date time. Okay, and if any change, for example, if there's any change you make to the raw data, you should keep, okay, you should not, it says, so as to not to obscure the original entry. That means you should leave the original entry there, and you should give a reason. Then it should date and the sign. Is this right practice, or do you need something more? Okay, so that those are two different statements. And what is the lab GLP clock? I put the quotation here. Okay, that means this is how you handle your GLP in your lab, how you handle that. What is the point you need to keep everything? Because before that, for example, if a study directed science protocol, that's the whole study, GLP will start. Okay, the GLP starts here for the whole study. But in your lab, you work on something, there's no way you can do any GLP. You don't have any samples. You don't have any the standards, so you do not have to do the GLP. It's good practice to have GLP. That's okay, but a lot of times you have too many unused data. You put it at different place. It's called exempt. So that's why I put a quotation there. It's called a GLP clock in the lab. So that's something we can discuss later. I know you know the answer already, but we don't have time to do it now. So what's the requirement for a set of samples? So for example, you have all kinds of samples, control samples, spike samples, calibration standard, solvent blank, field treated samples, or some other ones where you may have different ones, requirement. And what is the raw data? So for example, which one is the raw data? Okay, your lab Excel sheet calculated, and how about the protocol? How about some other notes, even balance log, or how about you call someone? You need to write something. Is that that's the requirement for in a GLP study as raw data, as a record? Okay. Oh, I think we put it twice there. That's okay. So the next one is the acceptance, and this is what we deal every day in the lab. So what is the requirement for your spike recovery, and do you need to have the multiple injection to make sure this is right? How many calibration points are there? And what is your sample holding times, the extract holding time, and what is the your spike levels, and if it is too high or low. So basically, this is most likely is the not the GLP requirement. It's related, but there should be the protocol requirement. And sometimes you may have more restricted requirement in your lab, so you write it in your SOP. So we have other questions there. So let's say for your data archives, how long you keep the data. So in some places, because there's a limited space for you to put it there, for some spaces they have the facility have the rules say, okay, you just need to keep it for 5 years or 3 years. So, and from which point this 5 years, 3 years, 1 year, 2 years. So, or sometimes maybe because this is GOP study, so study director can say, yes, keep it, or just simply dispose whatever you have. So, okay. Those are the questions or something. We spend a little bit time, but that's good learning. We will do this at the end of the training if we have the time. Let's start today's work. We talked about a lot of things about data yesterday, so we are going to use the law, the GLP law, to say this one more time. So what is raw data? Sometimes we call that raw data, or put another word there to make it more restrict or more easy to see, so call that original data or original raw data. Okay, so it depends on how you say that, but we do know these are meaning the real work you are doing, the paperwork, all those data, including electronic data. Okay, so even though let's say this is EPA GLP, we know EPA GLP was published in the I believe it's 89. Yeah, but I also started 2 years later. So FDA GLP 20th CFR, that's FDA. I think it's the 1970s. I don't remember. I'm not sure exact the date. I can find that out. So it's the 1970s. It started in the 1960s. So at that time, there's a lot of differences. A lot of them we don't know. For example, computers were not so popular at that time. So if you read the wording there, these wording are the same for this is FDA, and this one is the EPA. This is EPA GLP. Okay, so the wording are the same. Let's read the wording. Well, that time it says any lab worksheet. So you work on something, you write on something. So nowadays, you can also extend it into electronic sheet, electronic data, because as long as it's any laboratory-related worksheet, and all the records, the paper records, they meant that time, but you can say the electronic records is also this time, because right now everything is typed in the computer. In older days, everything's is written on the paper. So any related documentation like a memoranda, like all those things must be there. And any lab notes, including the true copies, exact copies. Okay, so you make a photocopy, that's fine. The older days, they don't, as what we use now, use a cell phone, take a picture like that. They don't use that often. So, and the results from the observation, activities. So, and all those, well, what we can tell, the keywords here is you need to have all the data to reconstruct your work, to evaluate work, which is the key word here. So everything you need to do is make sure I can go back to see exactly what you did. So if something happens, okay, and you need to go back, oh, what is the previous step? How this is leading to here. So that's the purpose. So of course, that time we don't have nobody knew the electronics or those computers going nowadays, and they did not have enough time to, enough knowledge to put all those requirements for electronic data or data keeping. So then later, I think it's probably around the year 2000 sometime, then FDA had another one. So it's 20th CFR section 11, 15th in section. Well, let's just write this down a little bit. So even though right now we are still using this for electronic data keeping, so the idea is the same. We call that section 11. or part 11, say part 11. So that's the electronic data. So electronic data, if you read exactly the same, it should be the same as this. If you have all the electronic related work, you need to have all those things. You have the work related worksheets, records, all those the documentations, the lab notes. You can type everything in, or you can do it. For example, if you weigh your sample, you put it on there. It will generate electronic data to your database. The LIMS laboratory information system will record the data automatically. So all those things, you should do the same way of this. So if you provide the data in the same way, they will accept. However, it depends on your work. Sometimes it's very hard to validate this. Not like a paper. Paper is here. I can tell this is my signature. Okay, I wrote the data. I can prove that. But electronically, you need to have a lot of knowledge, the IT knowledge, and a lot of other things. I know there's a lot of IT people up behind the scene helping us to do this training, and this is a big work there. It's a lot of workload. How can you make this work? Plus, we do the GLP work. We need to validate. We need to verify what's going on. So what we talk about now, another thing is on my computer, on my end, I take a piece of paper, I do the work, and that's no problem. This is the record. We can tell, but when this becomes electronic data to your end, how can you validate your data and this original data the same thing? So it's the electronic data. So that's getting very complicated. We don't have time to talk about this today, but that's the requirement is very the same to the paper. So right now, I would say if you can, do the best you can to print everything out, sign and date. And that's the best way to handle the data right now. Yes, you can use electronic data. Yes, you can, but that will make things very complicated. So if you cannot validate, a lot of things will for a pod, you may not be able to put things together. So again, this is a FDA GLP and EPA GLP. And again, it says what is raw data. So all the raw data here is everything. Is what? That time, okay, about 40, 50 years ago. So they say they take a picture, okay, photographs, it should be. Okay, that time is a microfilm, but of course, nowadays you can always say electronic related data. All those computer printouts, okay, all those magnetic media. So that's a big area, the electronic data, okay. All those, everything, if you can say everything related to observation, recording, and automated system. Even this is like a definition about the raw data, electronic data 50 years ago. It's still valid for nowadays. We do electronic data. We do our data keeping. So we are not going to go too much detail there. We just talk about the paper. That will be easier. So if you cannot handle electronic data or data keeping in your lab, it's better to keep it paper. I would say it's safer. At this point, I'm not that much knowledge to do the electronic data correctly. So I prefer myself the paper. So how we do the paper data? So and we say this is raw data. Well, I'm talking about the paper data now. If you can do exactly the same thing with electronics, you can do the same. So let's put the electronics on the side. Just talk about paper. So all those raw data, it should be recorded directly. So basically, you need to write it down on a piece of paper or print out on the paper. Not just going another way. That's called the data transcribing. You are just to take one data from one place to another. So you should record it directly, and it should be promptly. So that's way it doesn't mean how many seconds, how many minutes, but promptly, that means it's good time period you need to record your data. and it should be in the ink. That means permanent ink. For example, when you use balance, you weigh a sample. That's a very good question, how you do that. So, for example, I showed you yesterday the balance log. Okay, so we write on the balance log is the raw data. Let's say the log is the raw data. So when you use your lab note, and your log will say, okay, this is the weight 1, and this is weight 2 for your work. When you use your lab note, when you transcribe that data, that is not raw, that is the copied data. Because when you go to your lab note, you write down the same thing. Okay, so that lab note data is a copy. So this is copy. This is the original. So based on the definition here, you need to record it directly here. So that's the original raw data. Okay, and promptly. Okay, for those W1 and the W2, you know it's by how many seconds. You need to write it down. If you make a mistake, if you make something change, it should be how many seconds later you make correction. And there's a FDA finding for one lab. They made the balance reading change half year later. So for example, if you weigh something 10 grams to do the work, that's my example. That's not exactly EPA finding. It's 10 grams. And later, okay, there's a mistake found. So they cross this out. Okay, oh yeah, I made a mistake. Okay, this is a 9.8 grams, for example. That's exactly the same case, but not exactly the same number, of course. Then they change this. Oh, this is a 9.8 grams. Okay, and they did everything. And between here and here, okay, so between these, they put 6 months there. 6 months. So what do you think? You are the audience. You are the inspectors. What do you think? If the difference here is 6 months, do you trust this work? That means based on the definition, that's not the raw data. Something is wrong because it's not promptly. You cannot do that. So it depends on your work. So my recommendation is when you record your work, you do it immediately. Okay? If you write on the balance log, it should be immediately. If you write your lab note, you can wait a little bit. So my understanding is your lab note, everything should be the same day. That's the minimum requirement. Don't wait longer than a day. Otherwise, that's finding. That's wrong. But if you have a typo, if you have something wrong, you can do how many days later. That's okay because you always make a mistake, and later on when you read it again, you find a mistake. Then that's fine. So in this case, that's okay. So it should be promptly and should be permanent ink. Okay. So the raw data there are 2 things that must be on the raw data. One is signature, who did that. One is the date. Sometimes if it is necessary, that will add a time there, but date should be good enough for general purposes. And that's the FDA GOP and the EPA GOP here. So FDA GOP and the EPA GOP. So I'm pretty sure OECD GOP should be the same. So most important thing, it must have the signature, it must have the date on your raw data. Okay, so we talk about the change. So what is the change? What's the requirement? So yes, if you have a change, yes, you can. You make a mistake, you can make the change. First, you need to keep all the original there. You cannot change the original. Don't scramble this out. Oh, this is not right. No, that's not right. So you need to keep the original there. Okay. So if any reason, anything, you need to write the reason. Okay. You need to write the reason. Then again, because it's a raw data, you need to sign it and you need to date that. So that is. So you need to put your correct answer here. For example, if you make any change, you correct that. Then you put the correct answer right before or after that. Okay. So I don't have questions. That's fine. Okay. The signature most likely should be the person who is responsible for doing the work. Or sometimes your supervisor can override your work. For example, if electronic data, you need a higher rate to make the change, higher rank to make the change. So that's possible. Okay. And you need to identify that because your level, you cannot make this change, even though this is your mistake. So the higher level, if you are the IT person, you know that, it'll give you a different right. So if you are a user, you can only enter something. If there's need to change, you need a higher level, or maybe called the administrator's level to make some changes. So basically your boss, your direct boss can make certain corrections there. And that should be the same for the paper. If there is something like that, that person needs to sign and date. Okay. So, well, say that short, that should be the same thing for all data, but the purpose is reconstruct your work. So we can go through this quickly. This is too much to say. This is too much to say. There are some do's and don'ts. Okay. When you say do, you need to follow that. When you say don't, there's a lot of things there. Most likely people will say, yes, that's how you learn things is from the mistake, from don'ts, okay? Don't do that. That means you don't scribble any mistake. You just, if this is wrong, just simply cross that out. Okay, this is a mistake, okay? Then you, oops, wrong one. Then you make the corrections. Okay, then you say, oh, yeah, that's a different thing. Then I write something. This is the correct number. And this is ABC. Okay, the ABC is correct. Something like that. Okay, then you sign, always sign your name here and the date, the entry here. Always do that. Then that is okay. Of course, you always need to give a reason why you make this change. Oh, this is the wrong entry. Sometimes we call that a WE. I just want to add one statement here, one reason here, because sometimes this WE, if the answer is too short, nobody knows this is your answer, or this is your, because sometimes you initial, somebody's initial may be WE. So in my lab, we make it a little bit easier because you write the date and the signature together, that's your signature. So that's your signature here. And this is your answer, should be above that, beneath that, or on the side. It could be anywhere around. That should be around. And this reason, say wrong entry, WE, always put a circle there. So that tells the difference. Okay, and in this case, you don't make like a mistake or confuse people for doing so. So if something like this in my lab, it's very easy to see, and this is the reason. Okay, and this is the correct answer, and that's your signature and the dates. Okay. So these are all saying here, put it on the top, or all those things. Okay. So use permanent ink. And also older days, It's difficult to tell this is a photocopy or this is scanned copy, so we put the colored ink. It's easier for you to handle that. Even right now, we still use this rule because we still use black and white photocopy. So if you enter some data, so in my lab, if you want to say this original data, it should be always the blue color if you use a blue pen. Okay, so that's why nowadays a lot of things are like you have a pen. Okay, I will say 80% is the black color ink. So we buy our pens intentionally say this is blue ink. Okay, like that. Okay, and you can tell typically like this. You can see that. Okay, you can see the difference. Okay, then you write it down. That's easy to tell this is original raw data or this is a copy. Of course, if you read it carefully, you have something here, you read it carefully, you will find that out. Nowadays, their copy is getting better and better. Even we have the colored copy. So, okay. So, yeah, those are the things we learn there. We learn other thing. We know the time or we know everything, but most likely because the work efficiency. So the comment there, the suggestion is take your time. So write it slow. Write it slowly, make the commitment. Yeah, that's your work. That's the real quality of your work. Most likely, that's my experience. It's different from lab to lab and different from your work, difficulty of your work, and also the amount, the workload of your work. If you assign the work very well, you need to do, most likely you need to do 1 hour lab work. You will spend 1 or 2 hours to write. That's probably good enough for you to record all your data into the data system, data book. So that's a lot of time to do the documentation. Okay. So in this case, you need to spend quite a lot of time to do the work and to make the documentation. So yeah, if that another experience was if you make a mistake, it takes 10 times time to go back, correct them. So it's better to spend, for example, you spend 10 minutes to write something, and later you probably will spend an hour to fix that because you have to write the reason, you have to go through the QC, you have to go through the lab director, and if it is a deviation, you have to ask a study director to get approval. You have to keep all the records. So your paper, if it is 1 page of paper, now becomes 3, 4, 5 pages and takes really long effort. So if you can make 10 minutes, make them correctly, it will save 1 hour effort to try to fix it. So that's my experience. So do it correctly at the very, very beginning. Okay. We can give some examples. For example, today's date is 14th of August 2020. So this is the correct date, for example. Okay. And if you make a mistake, for example, if you write something wrong, like 2015, so the best way is to cross everything out. Then write your correct answer here on top of that or by side of that, and sign and date. Okay, then you sign or initial. Let's say we call that initial. That's probably better because a lot of time we just initial that. We don't sign the whole name. Okay, we just put the initial there. So that's called that INI, initial. Okay, and the date. Okay, so that is good. And of course, the format, the date format is also important. If your format is like this American format, like 8/15/2020, That's okay because you're SOP. And data, if you do international work, I would recommend write something complete like this, like 14 dash AUG dash 2020. So that's the good way to do. Okay. However, some people may make it a little bit easier. I do that myself. A lot of times I do. They just simply just cross this in. They just do that. And you make the correction. Okay, make, for example, 14 here. You make correction here. You cross that out. The same thing, initial and date. Okay. And also remember, you always also put the WE there, the wrong entry, because you made a mistake. Okay. So that's probably okay because you only crossed this portion. Okay. And sometimes you do, well, let me erase that. Looks like it's too many. Erase that. Could be 14. But, okay. So that should be okay. And sometimes people just cross one letter or one number. It is okay with some people, but I don't like that. Okay, so you have to put the reason there. You're this. So let's erase what we have. Well, let's do this. Let me erase that. Let's do it again. This is typical. Okay. Oops. Where's that? It's going too far. Okay. So if it is like that, it's easiest. Oh, it's here. That's the best way is this one. Go to the first one. Okay. So that's it. For the footnote, for all those related thing like a WE or something, it's your lab SOP. So this is, for example, this is my lab, something like that. Okay, so common sense is you can say most likely I will say more than 90% is your type wrong. So we always put error coding, say 1. And remember, I always say that we put a circle there. Same thing, if you put it there, you put a WE, wrong entry, circle. That's in my lab how we do that. Okay, so that WE stands for wrong entry. And this is most likely, this is more than 90% in your lab, that's the mistake. And there's some kind of human mistake. For example, if you run something, some other people come here. This happened one time in my lab. Someone is doing extraction and put a sample on the side, do next to the sample. And some other people come here, took the sample and just did his. And you have to write this down. And that's a human error because this communication pick up the wrong sample. This is not the wrong entry. This is a human error. So you need to write it down there. So in this case, you could use EC2 or HE. And there's some calculation wrong. It could be unnecessary. Some places there's no entry there, but you put an entry there. Sometimes it write everything, but after a while, it's not clean or clear to see. It's not eligible or something, or late entry. This is the second highest mistake. So you will see a lot of time LE, that stands for late entry. And rest of them are not so likely to see, except you see NA, which is just like a common English, general English, is just not applicable. That means you do not need to have anything there. Okay. So sometimes we put this recently in our system because if there is any empty box, there's a lot of question there. Why didn't you fill up the empty box? That's except to see some data there. This is no error at all from the top up to here. There's no error at all. It's not applicable. It is applicable. But sometimes there's no data, so we put a no NE, no data, no entry necessary. That's intentionally to leave it there for purpose. So this is the reason that we added there, because a lot of different questions. Okay, so that's the raw data. And That's how we handle that. Those are the two highest use in the lab. I'm quite sure. Okay, so then we can talk about the requirement from the protocol. What protocol requires to keep the record, and you can read that. Of course, this is very small, and you can read any IR4 protocol. It should be very similar. For example, the lab documentation keep okay, let me just quickly read that. It is necessary to be there. This is GLP requirement put in detail in the protocol. So all the analytical standards related information, like received, like use, like disposal, like storage, like dilution, like preparation. See, so that means all the documentation related to the standards should be there. When you receive the standard, you should get received. You need to get a communication with Syngenta, with Dow Agro, Corteva, with the Bayer, with all those companies. Okay, communication received. And when you use the standards, every single time you use that, you need to have a record, and you need to archive that, put it on the side in case there's any contamination. So even you take 0.01 gram, you need to have a record, and why you do that. Okay, I do the calibration, I do the spike, because you have to have 2 lines to do the work. And when you dispose that, okay, because after like 5 years, and it's all expired, you don't keep them. In my lab, we keep the standards permanently. We just keep it there. Even though it's expired, we put it on the side. So you need to have a record. You did that, or you put it somewhere. What's the storage condition? Okay, there. So it's in the freezer, refrigerator. What is the company requirement for you to do that? And all the preparation, so how you prepare the stock solution, the intermediate solutions, and your working solutions, how you prepare. You prepare them daily, or you prepare them just one time. Okay, then about the same thing for sample, for calibration. I don't need to say everything, but these are the key points in every single chromatogram. You need to have it there, even though it's not reported. Even though you say it's not used, even though. Okay. Sometimes we will call that word not used, which is a wrong word, but still commonly used in the laboratory. Because everything is used in the GLP. You cannot say not used. It's not used in your report. If you write the whole sentences, and I'm not using this in the report, but it's used in the GLP study. Okay, I made a mistake for the extraction, or the instrument is not good. There's a whole analysis, the whole set is not passing the recovery. So we're not using it in the report, but you still use that. So, but I put a quote there, unused data. Okay, then chain of custody, this is quite important there. Deviations, all those things. Okay, those are quite a lot there. Okay, so I don't need to show you how much data. I know each lab is different, but that will be a big binder, a lot of data there for like you do like a 5 trial study. Your data should be so big. That's commonly happen because you do need so much work to prove you did that and did that correctly. Okay, so let's just move on the next. So what is the golden rule? Okay, the golden rules are you document everything. So that means you write everything down. So what is everything? Everything related to your work. You call someone related to the work, you call the field from the lab. Oh, where's the sample? Okay, I'm ready to do the analysis. That part must be in your record. Okay, And when you pick up the sample from the freezer, that record should be there. So say that should everything. You not only document them, and you need to keep them. And a lot of times you write something on your hand, you need to keep that. On your glove, you write on your gloves, do a quick calculation, you need to cut paste that glove on your raw data. You keep, even though it's unused data. Okay, the QC is 68% recovery because the instrument is leaking. It's not that good. The retention time is shifting. Say it's unused data. So this is called unused for this purpose, but you are using for the GOP purpose. You have to keep that. Okay, and you need to write down all the necessary information. You need to write down the reason. And you need to initial and date for all raw data. So that's the requirement. Okay, what time is it? Okay, it's 7:06. Okay, let's do a little bit before we take the break. So important point, can your data be traceable from the first point to the next, like a chain of custody? Okay, is it producible, reproducible? Your work can be reproduced by other people. So if we put all these together, can it be reconstructed? So that means if something happens, for example, several days ago, there was an explosion in Mideast. I think that's in Beirut. Okay, so if something happens like that, there's big damage there. So what we can see now is the damage. So, okay, if this is sort of like an investigation, what you can see based on all your data to see what's really happening there, what happened, why. So that will track all the raw data and figure that out. Oh, this is the source. Something happened, then this happened, then there's an explosion, then finally you see whatever is there. So that's the evidence you need to connect. The same thing when we do our residue work, we need to build up the evidence like this. So that's the most important part. Okay, it's very interesting thing. We went through one question about the QA finding or FDA finding. This is the wording from FDA finding. You can find this on the web as well. Okay. If there is any data, something you just some key data, you just scribble like that. Eventually, people cannot see the original data, and that's the biggest finding because that's some kind of a shady thing there. This is the key number. If this number changes a little bit, you're going to affect the final results. So if it in this case, okay, the FDA finding is, okay, there's any absence of the raw data there, okay, then it will FDA. So if you don't see any data there, FDA does not have the, well, this is very wordy, very formal written, but FDA will trust your work, okay? And sometimes this kind of a correction was made 18 months. Is one question. You write some data there. Then when you submit the data to EPA, okay, we do exactly the same correct thing. Let's say we do this, okay, we do the data correction, we do the correction like this, cross this out, write a new data, okay, new data. Then you write a reason. This is a wrong entry, okay, and you put the signature there. We call that initial, and we put the new date there. This is good. Good practice. Is all right. This is exactly what we're supposed to do. However, this date is totally different. The original date here is 18 months ago to the new date. And you know, there's a lot of data you cannot cheat because it's all connected. You cannot cheat. And especially electronic data, it's always there. You cannot cheat. And in this case, after 18 months, you make this change. And if the number is an original number, all your work will be different. Do you trust this one? That means something's wrong. So that means that they find something wrong. This company is cheating. It's no good. So this is one finding, say 18 months is not good. If you say your balance log, your balance number, you make the correction, the number 3 months later, I don't trust you. It should be the same day, same time. Oh yeah, I weighed 10 grams. Oh, it's not 10 grams, it's 10.05. Of course, you read it that way, you change it immediately. It wouldn't be like 3 months later. Yeah, my recovery is 121. If I make this a little bit higher, then my recovery is 119. Then everything's good. Then that's wrong. So intention is wrong. Then this is something you intentionally try to cheat. So it's no good. And people can find that easily. This is not difficult to find. There's another one. Okay, it says any deviation there. This is some correction. Okay, if you say this is, I know what exactly the case that is. This is talking about the animal test, the toxicology test. They count how many the mice died in the work because they want to do the ED50. And in this case, they do the correction after 6 months. So how can you count that or a year later? How can you count that the death rate of 50%, the correction is 6 months later? I don't think the animal is lasting that long or your data is correct. So that's definitely something wrong. We can talk about electronic data, but it's just getting too long. That's another probably half an hour session. We are not going to talk about this today. Okay. When we have time next time, we can talk about that. And also, I mentioned if in your lab, do the best you can, do it on paper as necessary if you can. Paper. Okay, do the paper. Otherwise, it's difficult. If you have the resource, you have the knowledge, you can do the electronic data if you want. Electronic data keeping, electronic submission, or everything electronic is okay if you have the resource and you can do that. So what I recommend the paper at this point, because it's easy to handle and you can always go back to check the original raw data. You don't have the resource to validate your work, your data, and from the work to electronic. So that's what we recommend at this time. If you do the good laboratory practice work in your lab. Okay, it's 7:15 now. Maybe let's have just 5 minutes break, 10 minutes break. We will resume 7:25 New York time. Okay, is there any questions? You can, yeah, if you do, you type in the chat box so we can do the questions and answers while some people are using bathroom or take a break and something like that. Or some of you may be at the dinner time. Yeah. Okay, just have a quick break. We will come back in 10 minutes. 7:25 New York time. We will resume.